Hello, welcome everyone. Question is, four capacitors are connected to each other as shown in the figure. A says calculate the, as shown in the figure, A says calculate the equivalent capacitance. To calculate this, we have to solve this question step by step. We cannot calculate it directly. And as you see here, these two capacitors are series. So for the series combination, we must use the formula 1 over C equivalence is equals to 1 over C1 plus 1 over C2. By this formula, we can calculate the equivalent capacitance. So it will be what? 1 over 6 plus 1 over 3. So expand this with the 2, with 1 over C equivalence will be 3 over 6. So C equivalence will be 2 microfarad. So result of this it will be C equivalence. Let's say this one is prime, C equivalence prime. This one going to be 2 microfarad. And as you see, these two, they are parallel to each other. So for the parallel combination, the C equivalence equals to C1 plus C2. Here there is no C1, there is C equivalence prime plus C3. So C equivalent will be, let's say this one also C equivalent double prime, 2 microfarad plus C3 2 microfarad. So it will be 4 microfarad. And if we continue, let's draw the figure again. After this step, let's draw it again. New figure, it will be like that. That is C4, which is 4 microfarad. That is C equivalent double prime will be 4 microfarad. This one also 4 microfarad. So the resultant or equivalent capacitance will be what? And these two are series to each other. So for the series combination, 1 over C equivalence is equals to 1 over, that is C equivalence prime, C equivalence double prime plus 1 over C4. It will be 1 over 4 plus 1 over 4, because both 4 microfarad, so it will be 2 over 4. So C equivalence will be 2 microfarad. This is so it will be 2 microfarad. B says calculate the storage charge in each capacitor. It means Q1, Q2, Q3 and Q4. Calculate them, it says. And from the figure, if we redraw it again, simply, that is a C1, C2, C3 and C4. And I know C1 and C2, they are series. So Q1 and Q2 must equal each other. And so there is Q1, charge of it, there is Q2. And for this one, there is Q3. For this one there is Q4. And also Q1 plus Q3, because they are parallel to each other, must be equal Q4. These are the properties of their combination. So first of all, let's calculate Q total. And the total charge which flow in the circuit, it must be equal Q4. It is the series combinations rule. For the series combination, all the charges are equal to each other. For the parallel combination, the total charge equal sum of the charge, sum of each charge. So if I calculate the total charge, that means I calculate also Q4. So Q total is equals to C equivalent times V total. And delta V is equals to 40 volt. And C equivalent, as we calculated from A, C equivalent is equals to 2 microfarad. So 2 times 10 to the power of minus 6 times 40. So it will be 80. We can write it microcoulomb, or 80 times 10 to the power of minus 6, 80 microcoulomb. So Q4 is equals to Q total is equals to 80 microcoulomb. And I know Q1 plus Q3 must be equal Q4. So they must be equal 80 microcoulomb. And now let's calculate the Q3. And from the solution of A, I know I draw that again, as you remember. This will be 4 microfarad and this one is 4 microfarad. So delta V is equals to 40. So if I say this one V4 will be 20 volt from the series combination, because delta V is equals to V1 plus V2, sum of the potential differences, so they are equal to each other, so their potential difference must be equal to each other, so this potential difference must be 20 volt. And here it was C1, C2 and C3. So they are parallel to each other. C3, potentials of C3, it means V3 will be 20 volt. It must be 20 volt. So if we calculate the Q3, is equals to C3 times V3. C3 is equals to 2 microfarad times V3 is equals to 20. So it will be 40 microcoulomb. 40 microcoulomb. And I know Q1 plus Q3 is equals 40. Q3 is equals 40. So 40 microcoulomb. So total is 80 microcoulomb. Q1 must be 40. Q1 must be 40 microcoulomb. And I know Q1 and Q2, they are series to each other, so Q1 must be equal to Q2, so Q2 will be also 40 microcoulomb. So Q1 is equals to Q2, they are equals to 40 microcoulomb. Q3 is equals to 40 microcoulomb, and Q4 is equals to 80 microcoulomb. Now let's solve the C, and let's keep this because we're going to use this data. Yes, let's solve the C. The choice of C says to us stored energy in fourth capacitor. So stored energy in fourth capacitor is equals what? Stored energy in fourth capacitor. The formula of stored energy is equals half Q square over C, or half C V squared. Also it has another formula, but which formula do you prefer? You can use it, or you can check the givens. Due to givens, you can use it. And I prefer this one. Why? I know Q4, I know C4, so I'm going to use it. Half Q4 squared over C4. So it will be half times Q4 where, yes, where is the Q4? There is 80 times 10 to the power of minus 6 squared over, what is the C4? C4 is equals to 4 times 10 to the power of minus 6. So the result will be half times 80 squared, 6400, times 10 to minus 6 squared, 10 to minus 12, over 4 times 10 to the power of minus 6. And 2 times 4, 8, 64 over 8, 800 times 10 to the power of minus 12 will cancel each other. 10 to the power of minus 6, it will be 10 to the power of minus negative 6, and the unit will be in joule because we calculate the stored energy. So PE4 is equals to 800 times 10 to the power of minus 6 joule. That's all for the solution of C. Thanks for listening.